So question 3. So for the quadratic function f of x equals x squared minus 2, excuse me. For the quadratic function f of x equals x squared minus 2x, answer parts A through C. So part A has quite a few parts to it. So we want to graph the function by determining whether the graph opens up or down, and by finding its vertex, its axis of symmetry, its y-intercept, its x-intercepts, if it has any. So again, one of the first things we pick up on is in our function, the coefficient of the quadratic term tells you if it opens up or down. So our quadratic term is this x squared. So if I look at this function, f of x equals this x squared minus 2x, the coefficient of the quadratic term is a 1. So a lot of times the coefficient of x squared is defined by the variable a. So what we kind of say is if a is positive, in other words, if a is greater than 0, the graph is going to open up. If a is negative, in other words, if a is less than 0, it's going to open down. So it's going to open up. If it's positive, it's going to open down. It's negative. So if we notice the coefficient of the quadratic term is a 1, so that means there's not any kind of reflection. It stays opening up. So remember, if it was negative, that makes it going to open down. So our graph is going to open up because the coefficient of the quadratic term is a 1. To find the coordinates of the vertex, so we have a couple of formulas here. But the first one we want to talk about here is if f of x equals this ax squared plus bx plus c. To find the x value of the vertex, we can use the formula x equals negative b over 2a. We can use that to find the x value of the vertex. So again, in our problem, f of x equals x squared minus 2x. Notice that the a would be a 1, the b would be a negative 2, and the c would actually be a 0. Since there's not a constant, it would actually be 0. So notice that our b is a negative 2, so I have to take the opposite of negative 2, which is a positive 2, and I got to divide that by 2 times a, and since a is 1, 2 times 1 would be 2. Then I have to simplify that. 2 divided by 2 would be 1. And then to find the y value, we have to substitute the 1 in for x. So in my formula, x squared minus 2x, because remember, f of x is function notation for y. So that's also the same thing as y equals x squared minus 2x. So again, we have this input and output concept. So again, I'm going to be substituting in 1 for x to find the ordered pair. So when 1 goes in, what's the corresponding y value to that? Well, 1 squared is 1, 2 times 1 is 2, and 1 minus 2 would be a negative 1. So 1 negative 1 would be the vertex. So if I look at this on a graphing calculator, we have y equals, and if I put this x squared minus 2x into the calculator, if I graph it, does it look like that vertex is at 1, negative 1? So write 1. It looks like down 1 as well. It looks like we did good. So that's just roughing it out there. Now, if I actually want to find it, remember, that's a minimum value. So I can use the calculate button on the calculator. If I do second calculate, use number 3, left bound, okay. Go to the right of that vertex, because remember the vertex is the lowest point on the graph in this case. If I enter the third time, and notice how it takes me, and notice how it gives me this 0.999, which basically is 1, 1, negative 1. So that does verify that way as well. So again, sometimes they want exact answers, and that's where the algebra on paper comes in handy. So I think I put that in the wrong spot though. Oops. So that's what my axis of symmetry is. So my vertex goes up here, 1, -1. So make sure you have this formula down. To find the x-coordinate of the vertex, we can use this formula, x equals -b/2a. Now, to find the axis of symmetry, it's going to be the same thing as the x-coordinate of the vertex. So it's going to be the same formula, x equals -b/2a. But remember, this also represents a vertical line. So again, -b/2a, the opposite of -2 is a +2. 2 times a is 2 times 1 is 2, and notice how we get the same value. So again, the axis of symmetry is really just the x-coordinate of the vertex, but we have to write it as an equation. So we have to write it as x equals 1. So x equals 1 represents a vertical line that kind of divides the parabola into two symmetrical pieces. So next question is, what are the x-intercepts? So to find the x-intercepts, remember you have to set y equal to 0 and solve for x. So we're going to set y equal to 0. So the equation turns into the equation x squared minus 2x is equal to 0. Notice how I can factor out a common factor of x. So x comes out, and this leaves me then with this x minus 2. And again, to find the values of x, we can use the multiplication property of 0. The only way this can equal 0 is if one of these factors is equal to 0. So what makes this first factor equal to 0? Well, if you just set that equal to 0, notice it says, well, x has to be 0 to make it 0. So if you put 0 into this equation, notice how it does make it a true statement, because 0 times a -2 is going to still be a 0. So that would be a solution. It's also going to be called our x-intercept. And then if you set the x minus 2 equal to 0, that's going to give you x equals 2. So my two x-intercepts would be 0 and 2. Now, x-intercepts are also called zeros. So if I use my calculator, second calculate, number 2 is zeros. So it kind of works the same way as minimum and maximum. So I have to move to the left of my x-intercept, hit enter, move to the right of that x-intercept, hit enter again, and notice how it takes me to 0. So that's an x-intercept. Notice how that one also looks like that's a 2. But if I want to use the calculator, hit second calculate, number 2 will actually find the x-intercept, or 0 if you will. So the left bound stay left of the x-intercept, and then go to the right side of the x-intercept, hit enter again, and that should take me to the 2. So we can also see it from that perspective. So the next thing is we want to find the y-intercepts. So to find the y-intercepts, we have to set x equal to 0. So that means I have y equals x squared minus 2x. If we substitute 0 in for y, 0 in for x, that's going to be 0 squared minus 2 times 0, which is going to be 0. So the y-intercept is 0. You can also see on the graph that the graph does cross the y-axis at 0. So it does kind of verify there, looking at the graph. So they want us to actually use the graphing tool to graph this. So what they want us to do is they want us to plot the vertex and one more point. So again, I'm going to hit the graphing tool. What you have to do is plot the vertex, which is going to be the -1, or sorry, the 1, was it 1, -1? So the vertex was 1, -1. And then plot another point. An easy point to plot would be either one of the x-intercepts. So we add an x-intercept at 0, 0. Once you do that, it should also mirror the other point, which is the 2, 0. And therefore, you should start to see this graph materialize on your graphing tool. So you have to locate the -1, 1. 1, -1. And then an extra point, you can use one of the x-intercepts. And I can use the x-intercept 0. And notice that when you do that, it's going to create the parabola in the right location. So the next thing is determine the domain and range of the function. So the domain, again, remember, there aren't any domain restrictions. So the domain is going to be all the real numbers, -infinity to infinity. As far as the range goes, notice that it has a minimum value. Notice how important that vertex is, that 1, -1. Notice that the smallest y value is a -1, and then the graph kind of goes upward. And notice how there's arrows there. There aren't any upper bounds, so it goes towards infinity in the y values. So you would have -1. Again, that's got to be a bracket though, because we are including it. I got to make that look a little bit better than that. So we are including the -1, so it has to be a bracket towards then infinity, open. So infinity is always going to be open there. So again, if you look at your table as well, you'll kind of see that in your y values, the smallest y value that you're going to see is at the vertex. Notice that y is -1. And then notice that doesn't matter which side you go, it kind of mirrors itself. The y values are going up towards infinity. So if you go the other direction, notice how the y values again are doing the same exact thing. They're going up towards infinity. So again, you have to be in the x column for it to actually scroll though, all the way further. So that kind of matches what we're thinking. So the next question is determine where the function is increasing and where it's decreasing. So the function is increasing. Notice how again, we're looking from left to right here in that sense. So we're talking about the x values. So notice that my far left is -infinity. And notice how if you come down here to where x is 1, notice that's the turning point. It's going to turn and go back up. So it's going down until you get to the x value of 1. So that's the decreasing part. So the increasing part would be, notice how it's going to be going from 1 to infinity would be the increasing interval. So they usually close the endpoint there. So the 1 is going to be closed to infinity would be the increasing side of it. And then from -infinity to 1 is where it's going to be decreasing. So notice how that vertex is a critical spot here. That's where it changes from decreasing to increasing in my graph. So again, they did one interval notation there. Okay, so I think that concludes that question there, which was a lot of parts to it. So that's question 3.